In question 11, triangle ABC has vertices at A -2, -1, B 4, 6, and C 6 and -3. In part 1, we have to show that triangle ABC is isosceles and find the exact area of the triangle. Now, if a triangle is isosceles, it means two of the lengths are equal. So now we can first find the length of AB. So applying the distance formula, the length of AB will be equals to the square root of x2 minus x1. So we can take it as 6 minus minus 1. So that will become 7 squared plus 4 minus minus 2 squared. So that will become a 6 squared. So this will become square root of 49 plus 36. 49 plus 36 is square root of 85. So now finding the length of AC. So AC will be equals to the square root of, so this will become -3 minus -1. So that will become -3 plus 1, which will be equals to -2 squared plus, and x2 minus x1 will be 6 minus -2. So that will become 8 squared. So 64 plus, so this will be 64 plus 4. So that will become square root of 68. So this will become 4 plus 64, which is equals to square root of 68. And now finding the length of, so we have AB, AC. Now we can find the length of BC. So BC will be equals to the square root of, so -3 minus 6 will become -9 whole squared plus 6 minus 4. So that will become 2 whole squared. So this will become 81 plus 4, which is equal to square root of 85. Now, as these two lengths are equal, it means that the triangle is isosceles. Now, to find the area of the triangle, we can first make a triangle where AB and BC are equal in length. So, making a triangle over here first. Now, let's say this is A. We can start off with B over here, as AB and BC are equal. So, we can write it as A, B, and C up here. So AB is square root of 85, BC is also square root of 85, and this length is AC is square root of 68. To find the area of this triangle, we can divide it into two equal parts. So half of this length will become, let's call this point as x. So AX will be equals to square root of 68 upon 2. So this will become square root of 68 upon 2. Now to find, as this will become a right angle, so to find the area of half of the triangle, we have to find the length of bx. So applying Pythagoras theorem, we can write it as bx squared will be equals to square root of 85 whole squared plus, so this will become 68 root 68 upon 2 whole squared. So square root of 85, that will become 85. This will become 68 upon 4. So dividing 68 by 4, that is, so 68 divided by 4, that is 17. So this will become 85 plus 17. So this length will be, and there's a small mistake over here, as this is the hypotenuse. So this would have been subtracting over here. So there will be a minus sign. So this will be 85 minus 17. So bx squared will be equals to 85 minus 17, which is 68. So the length of bx will also be square root of 68. Now, once we have the height of the triangle, which is square root of 68, to find the area, we can apply the formula half base into height. So area will be is equals to half into height, which is square root of 68, and we can multiply it with the base. So rather than finding the area of two triangles separately, we know that the base is square root of 68. So this will become square root of 68. So square root of 68 multiplied by square root of 68, that will become 68, and dividing it by 2. So the area will be equals to 34. Now in part 2, it says the point D is the point on AB such that CD is perpendicular to AB. We have to calculate the x coordinate of D. Now to understand this, we can first make a line AB. Now this is the line AB, and D is a point such that it is such that CD is perpendicular to AB, which means that if this is the point C, it is perpendicular to AB, and this is the point D. We do not know the coordinates. Now to find the x coordinate of D, we can solve the equations of A, B, and C, D simultaneously. Now, to find the equations, first we'll find the gradient of AB. So the gradient of AB will be equals to, we can write the points A, B, and C over here. So the point A is -2, -1. The point B is 4, 6. So this is 4, 6, and the point C is 6, -3. And the first step, finding the gradient of AB, that will become 6 minus 1. So that will be 6 plus 1 divided by 4 minus 2, which will be 4 plus 2, which is 6. So the gradient of AB will be 7 upon 6. Now making the equation of AB, we can use either of the points A or B. So using the point B, we can make the equation of AB. So that will be equals to y minus y1, y minus 6 is equals to m, which is 7 upon 6 into x minus x1, which is 4. Now, once we have the equation of AB, to find the equation of CD, we need the gradient. Now, the gradient of CD will be the negative reciprocal of the gradient of AB as the lines are perpendicular. So the gradient will become minus 6 upon 7. We know that the point C is 6, -3. So we can make the equation writing it as y minus 3. So this will become y plus 3 is equals to minus 6 upon 7 into x minus x1, which will be equals to 6. Simplifying this, we can write it as 7y plus 21 is equals to minus 6x plus 36. Taking 6x on the left hand side, this will become 6y plus 7y plus 6x is equal to 36 minus 21, which is 15. So this is our second equation. And the first equation was y minus 6 is equals to 7 upon 6 into x minus 4. We can simplify it to write it as 6y minus 36 is equals to 7x minus 28. Simplifying this, this will become 6y minus 7x is equals to minus 28 plus 36, which is equals to positive 8. Now solving the two equations simultaneously, this is the second equation, 7y plus 6x equals to 15. And the first equation is 6y minus 7x is equals to 8. Now, as we have to find the value of the x coordinate of D, so we can cancel out the y values over here. So multiplying this equation by minus 6 and this equation by 7 to make the y values equal, this will become minus 42y minus 36x is equals to minus 90. This will become 42y minus 49x is equals to 56. So this will cancel out. This will become minus 36 plus 49. So minus 36 minus 49, that is equals to minus 85. So this will be minus 85x is equals to minus 90 plus 56, which is equals to minus 34. So the x coordinate will be, the negative signs will cancel out and the x coordinate will be 34 upon 85. And we can divide by 17 and simplify to write it as, so this will become 17 times 2 and 17 times 5. So the final value for the x coordinate will be x equals to 2 upon 5. In question 1, we have to find the coefficient of x in the expansion of 1 upon x plus 3x squared to the power 5. Now, the expansion formula of the expression a plus b to the power n is a to the power n plus nc1, a to the power n minus 1, b to the power 1, plus nc2, a to the power n minus 2, b to the power 2, and so on. Now, as we needed the coefficient of x, so we have to figure out which of the terms will give us a term in x. Now, to do that, we can first write the expression, which is 1 upon x plus 3x squared to the power 5. Now, to figure out which of the terms to use, we can use first figure out this value of r, which is an unknown. So in a, x is to the power minus 1. So this will become 5 minus r. And in b, as we are just dealing with the variable at the moment, so this is x squared and to the power r, and that will be equals to x to the power 1. Comparing the powers, we'll get minus 5r plus r, and this will be x to the power 2r, and this will be equals to 1. So adding the powers, this will become minus 5 plus r plus 2r equals to 1. So 3r will be equals to 6 and r will be equals to 2. So once we have the value of r as 2, we can write it as 5c2. A is 1 upon x to the power 5 minus 2, and b is 3x squared. So that will become 3x squared to the power 2. 5c2, if we substitute this in the calculator, so the value of 5c2 is, so 5c2 is equals to 10. So that will become 10 into, this will become 1 upon x cube, and this will become 9x to the power 4. So we can see that x cube and x power 4 will cancel, and we'll get a term in x, and 10 times 9 will be 90. So this will become 90x, or we can write that the coefficient of x will be 90. Question 2, we have to, the diagram shows part of the curve y equals to x cube plus 1 to the power half and the point P lying on the curve. We have to find the volume obtained when the shaded region is rotated to 360 degrees above the x-axis. Now the formula for volume is given as volume is equals to pi into the limit. In this case, that will be 2 and 0, y squared dx. Now in this question, y is x cube plus 1 to the power half. So this will become x cube plus 1 to the power half whole squared dx, and the limits are 2 and 0. So when we whole square, this will cancel out. The expression will be x cube plus 1, and the limits are 2 and 0. Integrating x cube, will get x to the power 4 upon 4, and integrating 1 will get x. Once we have integrated, now we can apply the limits. So the lower limit, the upper limit is x equals to 2. So that will become 2 to the power 4 upon 4 plus 2. And we'll subtract it from the lower limit, which is x equals to 0. So when x is equals to 0, this will become 0 upon 4 plus 0. So 2 to the power 4 is 16. 16 upon 4 is 4, and 4 plus 2 will become 6. And we can add pi to the final answer. So the volume will be 6 pi for the shaded region. In question 3, a curve is such that dy by dx is 6x squared plus k upon x cube and passes through the point P 1, 9. The gradient of the curve at P is 2. We have to find the value of the constant k. Now, the gradient of the curve at P is 2 and the x coordinate is 1. So we can write this expression in part 1 as dy dx is 2 is equals to 6 into 1 squared plus k upon 1. So this will be 2 is equals to 6 plus k. So the value of k will be equals to minus 4. In part 2, it says we have to find the equation of the curve. Now, as we have the expression for dy dx, which is 6x squared, the value of k is minus 4. So this will become minus 4 upon x cube, and we can write it as x to the power minus 3. Now, to find the equation of the curve, we'll have to integrate both the sides. So this will become y is equals to 6x cube upon 3. And this dx basically comes on the right-hand side. So we can write it over here. So this will become 6x cube upon 3. This will become 4x, increasing the power by 1. That will become minus 2. And we'll divide it by the new power, which is minus 2. And we'll add a constant. Simplifying this, we'll get y equals to 2x cube plus 4x to the power minus 2 plus c. Now to find the value of c, we can substitute the point 1, 9. So this will become 9 is equals to 2 into 1 squared plus 4 into 1 to the power minus 2 plus c. 2 plus 4 will become 6. So c will be equals to 9 minus 6. So this will, and there's a small mistake over here. So this will become 4 upon 2. This will be equals to 2 over here. So this is 2x to the power minus 2. So this will become 2 plus 2, 4 plus c. So c will be equals to 9 minus 4, which is equals to 5. Once we have the value of c, we can write the equation of the curve as y equals to, and this is a cube up here. This is 2x cube. So the equation of the line will be equals to 2x cube plus 2x to the power minus 2 plus 5. In question 4, the first, third, and 13th term of an arithmetic progression are also the first, second, and third terms of a geometric progression. The first term of each progression is 3. We have to find the common difference of the arithmetic progression and the common ratio of the geometric progression. Now, we know that the nth term of an arithmetic progression is given by the formula a plus n minus 1 into d. And the nth term of a geometric progression is given as a r to the power n minus 1. Now, a is 3, and for the third term, this will become 3 minus 1. So that will become 3 plus, so when we are talking about the third term of arithmetic progression, this will be 3 plus 3 minus 1, which will become 3 plus 2d. And the 13th term will be 3 plus 13 minus 1, which is 12d. For the geometric progression, the first term is a, which is equals to 3. And for the second term, this will become 3 into r to the power 2 minus 1. So that will become 3r. And the third term will be 3 into r to the power 3 minus 1, which is 3r squared. Now, as the first, third, and 13th term of this AP is the same as the first, second, and third term of a geometric progression. So we know that if we divide these two terms, this will give us a common ratio. As in a geometric progression, two terms. So if I divide the third term by the second term or the second term by the first term, that will give us a common ratio. So we know that the first term of the arithmetic progression is 3. The third term is 3 plus 2d. And the 13th term is 3 plus 12d, and they are in geometric progression. So we can write 3 plus 2d upon 3, which will give us a common ratio, will be equals to 3 plus 12d upon 3 plus 2d. Cross multiplying, we'll get 9. So 3 3 is 9 plus 6d. Then 2d times 3 will become 6d plus 4d squared is equals to 9 plus 36d. So this will be simplifying this, we'll get 4d squared plus 12d minus 36d, and 9 and 9 will cancel out. So this will become 9 minus 9 equals to 0. So we'll get 4d squared minus 24d equals to 0. Taking 4d common, this will become d minus 6 equals to 0. So the two values of d will be d equals to 0 and d equals to 6. As the common difference cannot be 0, so the value of d will be equals to 6. Once we have the value of d, now we can find the common ratio, as the common ratio was the third term of the arithmetic divided by the first term. So that is 3 plus 2d upon 3. So this will become r is equal to 3 plus 2 into 6 upon 3. So 12 plus 3 is 15. 15 upon 3 will be 5. So the value of r will be equals to 5. In question 5, a curve is equation y equals to 8x plus 2x minus 1 to the power minus 1. We have to find the values of x at which the curve has a stationary point, and we have to determine the nature of each stationary point. Now, for a stationary point, the dy dx, or the gradient of the curve, is equals to 0. We know that the equation of the curve is 8x plus 2x minus 1 to the power minus 1. So first, finding the dy dx, this will become 8x. When we differentiate, that will become 8. So minus 1 will multiply by the coefficient. This will become minus 2x minus 1, decreasing the power by 1, that will become minus 2. And multiplying it with the derivative of 2x minus 1, so that is 2. The expression for dy dx will be 8 minus 2 into 2x minus 1 to the power minus 2. Now setting it equals to 0 to find the values of x, this will be 8 minus, we can write it as 2 upon 2x minus 1 whole squared equals to 0. We can write it as 8 is equals to 2 positive 2 upon 2x minus 1 whole squared. Cross multiplying, we'll get 2x minus 1 whole squared is equals to 2 upon 8, which is basically 2x minus 1 whole squared is equals to 1 upon 4. Taking the square root on both the sides, so this will become 2x minus 1 is equals to, so when we square root 1 upon 4, that will give us a plus minus 1 upon 2. Now finding the values of x, so we can write 2x minus 1 is equals to positive 1 upon 2, and 2x minus 1 is equals to negative 1 upon 2. Taking 1 on the right hand side, we'll get 1 upon 2 plus 1, which is 3 upon 2. So this will be 2x is equals to 3 upon 2. Dividing 2, this will become x equals to 3 upon 4. So one of the x coordinates will be x equals to 3 upon 4. And this will be 2x is equals to minus 1 upon 2 plus 1. So minus 1 upon 2 plus 1 is a positive 1 upon 2. So x will be equals to 1 upon 2, and this 2 will divide. So that will become 1 upon 4. Once we have these two x coordinates, we have to find the nature. So for the nature of the stationary points, we need the double derivative. We know that the expression for dy dx is 8 minus 2 into 2x minus 1 to the power minus 2. So as dy dx is 8 minus 2 into 2x minus 1 to the power minus 2, finding the double derivative, this will become d square y upon dx squared. Differentiating 8, that becomes 0. So now differentiating this, the expression, this -2 will multiply by -2 becomes a +4 into 2x minus 1. The power decreases by 1, so that becomes -3, and we multiplied with the derivative of 2x minus 1, which is 2. So the expression for the double derivative becomes 8 into 2x minus 1 to the power -3, or we can also write it as 8 upon 2x minus 1 whole cube. Once we have the expression, we'll substitute x equals to 3 upon 4 first. So when x is 3 upon 4, this will become 8 upon 2 into 3 upon 4 minus 1 whole cube. And we'll substitute x equals to 1 upon 4, so that this will become 8 upon 2 into 1 upon 4 minus 1 whole cube. So this will cancel out. This will become 3 upon 2 minus 1 upon 2. So that will become 3 upon 2 minus 1 upon 2 is 1 upon 2 whole cube. As this answer is a value which is greater than 0, so when x is 3 upon 4, it is a maximum point. So we read it is a maximum point when x is equals to positive 3 upon 4, and this is 1 upon 2 minus 1, which will be equals to 8 divided by minus 1 upon 2 whole cube. So this will be less than 0, it will be a negative value. So when x is equals to 1 upon 4, it will be a so when it is a positive, it is greater than 0, it should be a minimum point. So this will be a minimum point when x is 3 upon 4, and it will be a maximum when x is equals to 1 upon 4. In question 6, the diagram shows triangle ABC where AB is 5, AC 4, and BC equals to 3. Three circles with centers at A, B, and C have radius 3, 2, and 1. The circles touch each other at points E, F, G lying on AB, AC, and BC. We have to find the area of the shaded region EFG. Now, to find the area of the shaded region, first we'll have to find the area of this triangle and then subtract it from the area of these three sectors. Now, if we have a triangle with the lengths 5, 4, and 3, we know that it will be a right angle triangle, as if you apply the Pythagoras theorem over here. So 5 squared will be equals to 4 squared plus 3 squared. So we can find each of these angles using the using sine, cos, or tan, or we can even use cosine rule to find these angles. So let's say if you have to find the angle CAB, so the length of BC is 3. Applying the cosine rule, which is c squared is equals to a squared plus b squared minus 2 into a into b cos of c. So c is basically 3 squared. So this will be 3 squared is equals to 5 squared plus 4 squared minus 2 into 5 into 4 cos of c. Rearranging the expression, we'll get 2 into 5, 10 times 4 is 40. Cos of c is equals to 25 plus 16 minus 9. So cos of c will be equals to 41 minus 9, which is 32 upon 40. And taking cos inverse and making sure the calculator is in radian mode, taking cos inverse of 32 divided by 40, so that will be equals to 0.6435 radians. So we can use the cosine rule, and even if we had used this, the trigonometric ratios to find this, so that this angle, the opposite length is 3 and the hypotenuse is 5, as this angle will be a right angle, as the hypotenuse has to be 5. So if we used uh, opposite over hypotenuse, sine theta is equals to 3 upon 5. So taking sine inverse, so if we take sine inverse of 3 divided by 5, that will still be 0.6435. Now, once we have this as 0.6435, we know that this angle will be, so we know that this angle will be 0.6435. This angle is pi upon 2. So this angle will be pi upon 2 minus 0.6435. So first we can write that the angle ABC will be equals to pi upon 2, as both of these angles will add up to pi upon 2. So that this will become pi upon 2 minus 0.6435 radians. So first finding pi upon 2, so pi divided by 2 is 1.57, and then subtracting 0.6435, this angle will become 0.9357 radians. So this will be 0.9357 radians. Now once we have the three angles of each of these sectors, we can apply the area of the sector formula, which is area of sector is given by the formula half r squared theta. Now finding the area of each of these three sectors. So first finding the area of AEF. So area of sector AEF will be equals to half into r squared. So in this case, the radius is 3. So this will become 3 squared multiplied by the angle. So this angle was 0.6435. Then the area of the sector, so this sector is CFG. So this will become area of CFG will be equals to 1 upon 2 into the radius, which is 1, whole squared multiplied by the angle. So in this case, the angle is pi upon 2. And then the area of the third sector will be area of, so that is BEG. So the area of sector BEG will be half into the radius, which is 2. So that will become, so the radius is 2. So that will be 2 squared and the angle is 0.9357 radians. Once we have these areas, now we can substitute these in the calculator. So the area of the first angle will be 9 multiplied by 0.6435, dividing it by 2. So that answer will be 2.89575 centimeters squared. For the area of CFG, that will be pi divided by 4. So this will be shift pi, will apply pi in the calculator and dividing it by 4. This area will be 0.7853 centimeters squared. And this will be 0.9357 multiplied by 4. And then dividing this by 2, we'll get 1.8714. So the sum of the areas of sectors will be, we'll add all of these three areas. So 1.8714, so 8714 plus 0.7853 plus 2.89575, that is equals to 5.55. So this will be equals to 5.55 centimeters squared. And subtracting it now from the area of the triangle. So the area of the triangle will be equals to half base into height. We know that as it is a right angle triangle, so the base is 4 and the height will be 3, or the other way around. So that will become half into 4 into 3. So this will be equals to 6. So the area of shaded region will be 6 minus 5.55 centimeters squared. So the final answer will be 6 minus 0.55, which is equals to 0.45 centimeters squared. Now in the mark scheme, if you look, the answer for the area of the shaded region is given as 0.464, as we have to give our answer to 3 significant figures. So if I subtract 6 from 5.55, this will become 0.450. Now this change of answer can happen because of some rounding off that has been previously done. So it is better to not round off the answers, and we should only round off the final answer and then give our answer to 3 significant figures. So this is the actual answer for the area of the shaded region. And if we give this answer as over here, so this will result in a loss of mark. So 1 mark will be deducted for the accuracy mark. So we'll have to make sure we do not round off the answers until the final part. In question number 7, the point P x comma y is moving along the curve y equals to x square minus 10 upon 3x to the power 3 upon 2 plus 5x in such a way that the rate of change of y is constant. We have to find the values of x at the points at which the rate of change of x is equal to half the rate of change of y. Now, when we are talking about the rate of change of x and the rate of change of y, so we know that the formula is dy by dt is equals to dy by dx multiplied by dx by dt. Now, in this question, it says that the rate of change of x is equal to half the rate of change of y. So we can write it as that dy by dt is basically twice the rate of dx by dt. So in place of dy by dt, we can write 2 into dx by dt is equals to dy by dx multiplied by dx by dt. Now dx by dt will cancel out. So as dx by dt will cancel out, so dy by dx will be equals to 2. So now we can find an expression for dy dx and put it equals to 2. So the equation of the curve is y is equals to x squared minus 10 upon 3, x to the power 3 upon 2 plus 5x. Differentiating this, we'll get dy by dx is equals to 2x minus, So this will be 3 upon 2 multiplied by 10 upon 3. So when we multiply 3 upon 2 by 10 upon 3, 3 will cancel out. So this will become 5. So this will be minus 5x to the power. And decreasing 3 upon 2 by 1, that will become 1 upon 2 plus 5x. So that will become a plus 5. Now equating it equals to 2, we'll get 2x minus 5x to the power half plus 5 is equals to 2. Bringing 2 on the right hand side, we'll get 2x minus 5x to the power half plus 5 minus 2, which is equals to 3. Now we can solve this equation by taking a substitution. So we can write y is equals to x to the power half. Now as y is x to the power half, so x will be is equals to y squared. So we can write the equation as 2y squared minus 5y plus 3. So we can now find the values of y, and then using the substitution, we can find the value of x. So factorizing this, we'll get 2y squared minus 3y minus 2y plus 3 equals to 0. Taking y common, this will become 2y minus 3, and taking 1 common over here, we'll get 2y minus 3 equals to 0. Simplifying, we'll get y minus 1 and 2y minus 3 equals to 0. So the value of y will be y equals to 1 and y equals to positive 3 upon 2. Now once we have the values of y, we can find the value of x as x is equals to y squared. So over here, when the value of y is 1, so this will be x is equals to 1 whole squared. So x will be equals to 1. And the other value of y is 3 upon 2. So this will become 3 upon 2 whole squared. So the second value of x will be x equals to positive 9 upon 4. In question 8, part 1, we have to show that 3 sin x tan x minus cos x plus 1 equals to 0 can be written as a quadratic equation in cos x, and hence we have to solve the equation 3 sin 10 minus cos plus 1 equals to 0 for x 0 to pi. So in part 1, as we have to bring our equation in terms of cos, so we can write tan as sine upon cos. So this will become 3 sine into sine upon cos minus cos plus 1. So we'll get 3 sine squared over here, and this is equals to 0. So taking the LCM, we'll get 3 sine squared minus, so as the denominators are 1 over here, so cos will multiply by cos and become a cos squared. 1 into cos will be cos upon, so this will be upon cos equals to 0. Now this cos will multiply by 0 and become a 0, and we know that the identity is sine squared plus cos squared equals to 1. So sine squared can be written as 1 minus cos squared. So we can write this as 3 into 1 minus cos squared plus cos equals to, so cos into 0 is 0. Expanding the bracket, we'll get 3 minus 3 cos squared minus cos squared plus cos equals to 0. Simplifying, this will become minus 4 cos squared plus cos plus 3 equals to 0. And to make the square term positive, we can write it as 4 cos squared minus cos minus 3 equals to 0. Now factorizing this, we'll get 4 cos squared minus 4 cos plus 3 cos minus 3 equals to 0. Taking common, we'll get cos minus 1 plus taking 3 common, this will become cos minus 1 equals to 0. So simplifying this, this will be cos minus 1 and 4 cos plus 3 equals to 0. So one of the values of cos theta, so that the variable is x, so this will be cos x will be equals to 1 and cos x will be equals to minus 3 upon 4. Now in the first step, we find the basic angle. So in this case, this will be cos inverse of 1. And over here, the basic angle will be cos inverse of 3 upon 4. When finding the basic angle, we do not use the negative sign. Now, cos inverse of 1, when we substitute this in the calculator, so in that case, the basic angle will be equals to 0. And substituting cos inverse of 3 upon 4, so that will be equals to, so shift cos inverse of 3 upon 4, that is equals to 0.7227. Now, once we have the basic angles, now we can find the values of x. Now, as the x values are from 0 to pi, so in this case, we'll just make cos in the first quadrant, as the range is from 0 to pi, which is basically 0 to 180. So 0 will be made in the first quadrant, and for the basic angle 0.7227. Now, in this case, cos is negative, so we'll make cos in the negative quadrant, which is the second one. So we'll make the basic angle over here, which is, So this angle will be 0.7227. So x will be pi minus 0.7227. So one value of x will be x equals to 0 and the other value will be pi minus 0.7227. So pi minus 0.7227, that is equals to 2. So one of the values of x is x equals to 0 and the other value is pi minus 0.7227, which is equals to 2.4188. Giving an answer to three significant figures, this will be x equals to 2.42 radians. So these are the two values of x equals to 0 and x equals to 2.42. In part 2, the question is, we have to find the solution of the equation 3 sine 2x tan 2x minus cos 2x plus 1 equals to 0 for x 0 to pi. Now this is the same equation as the one in the first part, but the only difference is we have 2x instead of x. So the solutions that we had before cos x equals to 1, we can write it as cos 2x will be equals to 1 and cos 2x will be equals to minus 3 upon 4. We already know that the basic angle in both the cases was theta is equals to 0 and over here theta was is equals to 0.7227. Now this 2x basically represents a second revolution, so it means we can have more than the two values of x that we previously had. So when it is 2x, so we add 2 pi to the answers, so this will become x will be equals to the one of the values of 0. We can add 2 pi to this answer and this will be 2x. So 2x will be equals to 0 and 0 plus 2 pi. So over here the x values will be 0 and 2 pi divided by 2 will become pi. Now when the basic angle is 0.7227 and it is a negative value, so we'll make 0.7227 over here. So one value that we already had from the previous part was 2x will be equals to, so that value was 2.42 and we can make 0.7227 in the third quadrant as well, as cos is negative in both of these quadrants. So adding pi to 0.7227, that will be equals to, so that is equals to 3.86, 3.864. And now as it is 2x, we can add 2 pi to both of these answers, but as when we divide by 2, the answer will be above pi. So we'll just leave it to these two values. Now dividing both of them by 2, so 2.42 divided by 2, that will become 1.21. And dividing 3.864 divided by 2, so that will be equals to 1.932. Now, as we have to give our answers to three significant figures, so the final answer will be x is equals to 1.21 and the second answer will be 1.93. Now we can add 2 pi to both of these answers, but when we divide by 2, it will always be less than pi. So we'll have to leave our answers to x 1.21 and x 1.93, and the other two values are x0 and pi. In question 10, the function f is such that f of x is equals to 2x plus 3 for x greater than equals to 0. The function g is ax squared plus b, where a, b, and q are constants. The function fg is 6x squared minus 21 for x less than equals to q. In part 1, we have to find the values of a and b. Now, as the function fg is given, if we have to find the function fg of x, it means that in the function x, we'll replace it with the function g. So as it is 2x, the x will be replaced with the function g, which is ax squared plus b, and this is a plus 3 up here. Now as this is equals to 6x squared minus 21, so we can expand it and write it as 2ax squared plus 2b plus 3, and that is equals to 6x squared minus 21. Now comparing the coefficients, on the left hand side, the coefficient of x squared is 2a, on the right hand side it is 6. So 2a will be equals to 6 and a will be equals to 3. The constant term on the left hand side, that is 2b plus 3. So we can write 2b plus 3 and that will be equals to minus 21. So taking 3 on the right hand side, this will be 2b equals to minus 24 and b will be equals to minus 12. So the values of a and b are a equals to 3 and b equals to minus 12. In part 2, we have to find the greatest possible value of q. Now, q is basically the value that the function g is taking over here, and for fg of x, it is also the domain of fg function x less than equals to q. Now, we know that for the function f, x has to be greater than equals to 0. And when we form the function fg of x, it basically means that this x is now replaced with the function g of x, which means that as this x has to be greater than equals to 0 as given in the question, it means that this g of x function must also be greater than or equals to 0. So in part 2, as we know that the g of gx function is now the value of a is 3 and b is minus 12. So we can write that g of x is equals to, in place of a, we can write 3, and this will be 3x squared minus 12. So to find the value of x, which is basically the value of q, we can write it as 3x squared minus 12 has to be greater than or equals to 0. Solving this, we'll get 3x squared is greater than equals to, taking 12 on the right hand side, we'll get 12. So x squared will be greater than equals to 4. Taking the square root, we'll get x is greater than equals to plus minus 2. Now, as the question said that x has to be less than or equals to q, so we have plus minus 2, both of these values over here. Now, if we make this function over here on a quadratic graph and the values of x are 2 and minus 2, so this is 2 and this is minus 2 up here. So as this value has to be less than a particular value, so we'll take that as x has less, x will be or the value of q basically will be, so q will be less than or equals to minus 2, or we can write that q will be equals to minus 2. Now, for this to be greater than 0, it would have been greater than 2, so we would have taken the values x greater than equals to 2 and x less than equals to minus 2. So as in the question it states that x has to be less than equals to q, so we'll have to take this value which is minus 2, so q will be equals to minus 2. It is now given that q is equals to minus 3, we have to find the range of fg. So in part 3, we know that the fg function fg of x is equals to 6x square minus 21, and x is less than equals to the value of q is given as minus 3. So we can substitute x equals to minus 3 into this equation. So fg of minus 3, substituting 3 minus 3 over here, we'll get minus 3 squared is 9. So 6 times 9 is 54. 54 minus 21 is 33. Now this value, as x is less than minus 3, so even if we take minus 4, minus 5, minus 6, all of these will become positive and this will keep on increasing, which means that the range for the fg function, we can write that fg of x. So fg of x will be greater than or equals to 33. In part 4, we have to find an expression for fg and state the domain of fg inverse. Now the fg function is 6x squared, so fg is equals to 6x squared minus 21. To find the inverse, we can first write it as y is equals to 6x squared minus 21. So this is not a 1 up here, this has to be a 21. So 6x squared minus 21, exchanging the values of x and y, this will become x is equals to 6y squared minus 21. Taking 21 on the left hand side, that will become x plus 21 is equals to 6y squared. Now dividing by 6, we'll get y squared is equals to x plus 21 upon 6. Taking the square root, this will become y will be equals to the square root of x plus 21 upon 6. So we can write that the fg inverse function will be equals to the square root of x plus 21 upon 6. Now it is also asking us in the question to state the domain of fg inverse. Now the domain of fg inverse will be basically be the range of the fg function. Now the fg function was greater than equals to, so this would have been a 33 up here, which means if the range is for the fg is greater than 30, greater than equals to 33, it means that the range for fg inverse function will be x is greater than or equals to 33.